Okay, in this video we are going to learn how to analyze the data using the descriptive statistics, especially for the ratio variables. And we also will learn about how to show the charts for our data. So firstly, we can open the existing data that we have on our SPSS file, and because in this file you have different types of data, you see that this is the ratio, and this is the ordinal, and this is the nominal data. It's also the ratio data. So we will focus more on the ratio data for this video, right? First of all, we can click the Analyze, Descriptive Statistics, and the Frequency. Okay, so there will be 5 variables. We click the ratio data, which are the score and the age, and click the statistics, and we can choose the central tendency. Yeah, you can click all of them, or you can only choose which one that you want to show. And then the dispersion is the variety of the data, whether the data is spread variously or whether it is homogeneous data. We can click the standard deviation, variance, range, minimum, maximum, and also the distribution. It is to know whether the data is distributed normally or whether it's skewed to the left or to the right. And we also need the curtices. We can click continue. And for the charts, we can choose here. You have the bar charts, pie charts, but I will choose the histogram with the normal curve shown on the histogram. And click OK. Yeah, so we already have the result. Take a look in the first table, about the statistic here. So there is valid data. You have 20 items for score, the average score, and then for the student's age. So it means that all the data are valid, and then there is no missing data. And for the mean is the central score of the overall data. It shows, or the average score from our data, and we get 79.7095. And for the age, we get 14 years old. Okay, and median is also the central score of our overall data, but with slightly different calculation. And usually median is more representing the data when we have extreme scores in our data, rather than using the mean, in which these extreme scores might influence the result of the mean. We can use the median instead to really represent the central score of our data. And we see here that the difference is not that far. For the age, it shows the exactly same score for the mean and median. So it means that our data is not really extreme. And then for the mode is the most frequently occurred score in our data, and it shows 18.9 as the most frequently occurring scores in nilai rata-rata, and 14 years old in usia siswa. Standard deviation is the difference between the whole score with its mean in each variable. And we get here the standard deviation for nilai rata-rata is 8.6 something, while for usia siswa we have 0.795. And the bigger the standard deviation means that the data is more heterogeneous. On the other hand, the smaller the standard deviation is, means that our data is more homogeneous. And then, so it means that in nilai rata-rata, our data is more heterogeneous because it has like big standard deviation. While in usia siswa, we have more homogeneous data because the standard deviation is less than 1. And then for variance is to understand the homogeneity of our data as it shows in the standard deviation. And the higher the variance score, it means that our data is more heterogeneous, yeah. And then skewness, it is related to the distribution of the variables, yeah. And then skewness is like whether our variables is distributed normally, in which they are, or whether there is a tendency of our data distributed more to the left side or low scores, or more to the right side or. And then the kurtosis is like the tendency of the slope, yeah, whether the slope is too sharp or whether the slope is only like normal slope. And from these two scores, from skewness and also from the kurtosis, we can find the ratio of the skewness by using the score of the skewness divided by the standard error of the skewness, and we will get the ratio. And for the ratio of the kurtosis, we can also calculate it by dividing the score of the kurtosis with the standard error of the kurtosis. And if the ratio of the skewness or kurtosis ratio is lower than plus minus 2, so it means that the data is distributed normally. However, if the skewness ratio and the kurtosis ratio is higher than positive or negative 2, it means that the data is not distributed normally. Yes. 0.363 divided by 0.512, so it's like 0.7 something, so it's less than 2, so it means that the data is still distributed normally for nilai rata-rata. Like using the kurtosis, minus 1.366 divided by minus 992. It's 1.37 something, and still it's less than 2, so it means that the data is distributed normally. Range is like the point of difference between the maximum and the minimum score, and we have 23 points and here we have 2 points. We can get the range from the maximum score minus the minimum score. 15 minus 13 means 2, and then this one 89 minus 66 is 23. And for the sum, it's the total score of the data. So that's all for interpreting the first output. Now go on to the next output, which is the frequency table. Here we have 2 frequency tables. First is for nilai rata-rata and the second is for usia siswa. We can see here like the frequency for 13 years old we have 6 students, and then 14 years old we have 8 students, and then 15 years old we have 6 students. The mode is 14 years old. This is the histogram. Histogram here shows or describe the whole data in each variable, and we have 2 histograms. The first is for nilai rata-rata, and then this is the normal curve. Here it's not really distributed normally, but still, for the histogram here you can see and you can compare it with the normal curve of distribution of the data, and the scores that have highest frequency is on the highest score on our data actually. And here for usia siswa it is really distributed normally, because we only have like 13 years old, 14 years old and 15 years old. And our data shows that this is 6, 8 and 6. So the comparison between the histogram and the normal curve of data distribution is like this. Okay, so I think that's all for descriptive statistics, especially for the ratio data. I hope you can do it by your own after you watch the video.